So now we're going to build on what we learned yesterday. Yesterday we learned to evaluate simple exponential expressions. Now we're going to look at algebraic expressions with multiple variables and different exponents. Take a look at the first example. Make sure you write these examples down in your journal or on your note sheets. So our first example, we are asked to evaluate x squared plus y cubed if x equals 6 and y equals negative 2. So my first step is I'm going to substitute the values that I'm given for x and y. So x is 6, so this means 6 squared, plus y is negative 2, so this means negative 2 cubed. Now, I put that negative 2 in parentheses for a reason. I'll explain that a little bit more later. But I just want to make sure that I do negative 2 times negative 2 times negative 2. Okay? Let's take a look. Let's break this down now. So I've got to do 6 to the power of 2. That simply means 6 times 6. And then I'm going to add that to negative 2 to the power of 3. So that means negative 2 times negative 2 times negative 2. Okay, let's evaluate that. Exponents first. So 6 to the power of 6 to the power of 2, is 36. I'm going to bring down that plus sign and carefully evaluate this. Negative 2 times negative 2 is positive 4. And positive 4 times negative 2 is negative 8. Let me just write that out for you over here so you can see that slowly. I'll do that again. So negative 2 times negative 2 is positive 4 because a negative times a negative is a positive. And then we take that positive and we multiply it by the next factor, negative 2. And then we have a positive times a negative, and that's why we get negative 8. Okay, let's go back to our problem over here. Now we add, addition is last in the order of importance with order of operation. So I evaluated the exponents first. It would not be okay of me to have done 36 plus negative 2 and then multiplied these. I have to do the exponents first. And now I'm going to add. When I have a positive and a negative, remember I actually subtract those. So 36 minus 8 is 28. And then I keep the sign of the bigger value. I have more positive numbers here than negative, so my answer is going to be positive 28. Now I'm going to give you 3 more examples, and I'm going to have you try some. All right, take a look at this one. I'll write it a little bit bigger for you. It says 10 plus b squared, and it tells us b is negative 2. So first thing, I'm going to substitute negative 2 for b. Okay, next thing I'm going to do is evaluate the exponent because exponent evaluation is more important than adding. So negative 2 times negative 2 is positive 4. And then I add the 10 to get my final answer of 14. So 10 plus b squared is 14. Let's look at another one. Look at this one. In this one, I've got 2 variables inside parentheses and then being raised to the power of 3. So let's substitute first. A is 5 plus b is negative 2, and they're in parentheses, and then they need to be raised to the power of 3. This one's a little different. Because the 5 and negative 2, the addition problem, is inside parentheses, I'm going to do that first. So 5 plus negative 2 is 3. And now I'm going to raise that to the power of 3. You may be thinking, but Ms. Hill, why are you adding before doing exponents? Only because the addition problem was inside the parentheses and the exponent is outside. So I have to do the problem inside that parentheses first. Okay, so now 3 times 3 times 3. No, it's not 9. Think about it. 3 times 3 is 9, and 9 times 3 is 27. So my answer there is 27. Let's look at the one I consider kind of the hardest here. 2 minus c squared. And c is 3/4. So 3/4 squared. Okay. So I've got a fraction here, so I need to be careful about that. In this case, the 2 minus is not in parentheses, so I'm going to evaluate the exponents first. So 3/4 times 3/4. I just have to remember how to multiply fractions. This is a pretty easy one. 3 times 3 is 9. You just multiply the numerators, multiply the denominators. 4 times 4 is 16. So I've got 9/16. Okay? Now I'm going to bring down the 2 and the minus sign, and I have a slightly harder part here, adding and subtracting fractions. And I hope you remember the rules for adding and subtracting fractions. I've got a whole number, and I'm subtracting 9/16. Well, if you remember, when we add and subtract, we need common denominators. We need a common denominator. So what I could do here is I could do one of two things. I could change this 2 wholes into an improper fraction and make it out of 16. So think about it for a second. How many wholes, how many 16ths would be in 2 wholes? This is basically like 16 16ths and another 16 16ths. Isn't it? 2 wholes? So that would be 32 16ths. 16 plus 16 is 32. Now I can minus the 9 16ths. Once I change that to an improper fraction, I can now subtract. So 32 minus 9, and that will give me 23 16ths. And that's an improper fraction, so I do a little division and turn it back into a mixed number. 16 goes into 23 one time with a remainder of 7. And there's my mixed number, look. 1 and 7 16ths. There's my final answer. 1 and 7 16ths. There's my final answer. Now I want to show you, back a few chapters ago, we called this the hard way. It's actually faster, but a little more complicated to grasp. Let's back up here on this problem and see if any of you remember how to do this problem a little bit faster. See if you can follow me on that. Again, the beauty of these videos is you can pause me, you can rewind me, you can repeat it and watch this as many times as you have to until you understand it. Okay, so one other thing I could have done here is I could have just simply done a little regrouping. I could have made this 1 and 16 16ths, couldn't I? Isn't 2 wholes the same as 1 whole and 16 16ths? The reason I need this is so that I can take away this fractional part here. If I have 16 16ths, now I can take away the 9 16ths. So 16 minus 9 is 7 16ths. And then I have this 1 whole minus no whole. I get the answer a little bit faster. And I'll bet that some of you can even do this in your head. You can visualize 2 wholes, take away 9 16ths as a fractional part, and you could get that answer in your head. So I know we're all at different stages in how well we understand fraction. I'd like you to try some now. So I'd like you to pause the video, and I would like you to try these 3 problems. This is like a real-life example about North American hockey rinks. They're built according to National Hockey League specification. And I'd like you to evaluate each expression to find these dimensions. Okay, so find what 2 to the 6th power feet would be. Find 2 to the power of 3 times 5 to the power of 2. And then, ooh, this is going to be a hard one. See if you can figure that one out. Pause the video. Unpause when you're finished and we'll go over them. Okay, let's start with the easiest one. I hope this was easy. I hope you understood it. 2 to the power of 6 simply means 2 times 2 times 2 times 2 times 2. 2 times itself 6 times. No, it's not 12. I hope you didn't do that. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Again, you might have to start writing these down, writing them out. 32 times 2, I hope you got 64. Let's check this one. 2 to the power of 3 times 5 to the power of 2. 2 to the power of 3 means 2 times 2 times 2. And then we're going to multiply that times 5 times 5. because I have all multiplication here, order is actually not important. But I'm going to go ahead and evaluate the powers first. 2 times 2 is 4. 4 times 2 is 8. And then 5 times 5 is 25. And then you got to do 8 times 25, and that will give you 200. Hopefully you got that. Let's go over the most difficult one here. And I'm going to move all this out of the way. Because we're going to need some space for this one. Get rid of that and that. Okay, so x squared minus y cubed. If x is negative 5. So we've got negative 5 squared minus y is 5.3. Ooh, a decimal. 5.3 to the power of 3. I wouldn't say this one is hard, just very detailed. You got to be real careful about your work here. So here I have negative 5 times negative 5. And a negative times a negative is a positive. So this would give me positive 25. I'm just going to bring down the minus sign here. And this means 5.3 times 5.3 times 5.3. Okay, let's see how you did. So 5.3 times 5.3. 3 times 3 is 9. 5 times 3 is 15. 3 times 5 is 15. 5 times 5 is 25. And 1 is 26. Now I'm going to line them up and add them up and carefully count the decimal places. So I get 28.09. Be careful though. I hope you notice that we've only done 5.3 times 5.3. We now have to take that product and multiply it by another 5.3. So now I have to do 28.09 and multiply that by 5.3. Okay, let's check that one. 9 times 3 is 27. That's 0 and 2. 8 times 3 is 24. 2 times 3 is 6 and 2 is 8. Put down my placeholder and erase my regrouping. 5 times 9 is 45. 0 times 5 is 0 and 4 is 4. 8 times 5 is 40. 2 times 5 is 10 and 4 is 14. I'm going to add it up carefully. And then I'm going to carefully place my decimal. Watch this. 1, 2, 3. 1, 2, 3. So I've got 148 and 877 thousandths. That was a lot of work. I told you this one is going to be a lot of work. So now I've got to subtract these two. I've got a weird situation. I've got a smaller number subtracting a bigger number. Well, I know when I subtract, I'm going to get a negative. Because if I'm subtracting a bigger number from a smaller number, I'm going to get a negative. So now I'm going to find the difference between these two. 148.877. And I'm going to subtract 25. Watch this. My 25 goes here because it's 25 wholes. So these are going to be zeros. Got to be careful how you line up your numbers. Be neat as well. It looks like my final answer is negative 123 and 877 thousandths. Woo, that was a lot of work. Not difficult, I hope, but just a lot of work. We'll practice this some more tomorrow, and practice makes better. I'll see you then.